So we'll start by letting n equal 0. Left hand side we have e to the x cos root 3x, and on the right hand side we have 2 to the power 0 times e to the x cos of root 3x plus 0. So that is e to the x cos root 3x. Left hand side equals right hand side, so true for n equals 0. Our next stage then is to assume for n equals k. And in that stage we're going to say dx dk of e to the x cos root 3x equals 2 to the k e to the x cos of root 3x plus k pi over 3. And what we want to do is then let n equal k plus 1. So we want dk plus 1 of dx of k plus 1, and that is the differential of dk dxk. So we're actually differentiating 2 to the power k e to the power x, the cos of root 3x plus k pi over 3. Whenever we differentiate that, we have a product. So u equals e to the x, and du dx will equal e to the x. V equals the cos of root 3x plus k pi over 3. So whenever we differentiate that, we get minus root 3 sine of root 3x plus k pi over 3. If we bring that together then, our differential will be 2 to the power k uv dash, so that's minus e to the x root 3 sine of root 3x plus k pi over 3 plus e to the x cos of root 3x plus k pi over 3. So that gives us 2 to the power k e to the power x cos of root 3x plus k pi over 3 minus root 3 sine root 3x plus k pi over 3. Next section I'm going to do by considering what I know is going to have to be in my solution. And in my solution I need a 2 to the power k plus 1. I have 2 to the power k, so I'm going to divide that by 2. If I bring that over 2 inside the brackets, so we have 2 to the power k plus 1 e to the x, we have 1/2 cos root 3x plus k pi over 3 minus root 3 over 2 sine of root 3x plus k pi over 3. The next section focuses on the half and the root 3 over 2. We know that half is either the sine of pi over 6 or the cos of pi over 3. And if we think we want to end up with cos, if we think about our addition formula, if we have cos, cos, sine, sine, then we can rewrite this in terms of cos. So 2k plus 1 e to the x cos of pi over 3, which is 1/2, cos of our bracket minus the sine of pi over 3, which is root 3 over 2. Sine of our bracket means we have 2 to the power k plus 1 e to the x cosine of pi over 3 plus root 3x plus k pi over 3. So that is 2 to the power k plus 1 e to the power x cosine of root 3x plus k plus 1 pi over 3. If we take the right hand side, we will get 2 to the power k plus 1 e to the power x cos of root 3x plus k plus 1 pi over 3, which means that left hand side equals right hand side. So that's hence true for n equals k plus 1 and by induction true for all n.